You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. For over 75 years, Batesville Products has been engineering, casting, machining, inspecting, and polishing aluminum castings for over 70 industries nationwide. In today's episode, we'll continue to share our experience and industry secrets. Casting Class is in session.
Well, welcome everybody to our live event, How to Design for Permanent Mold Castings. My name is Jonathan Johnson. I'm a regional sales consultant. I'm from St. Louis, Missouri, and I'm going to be your moderator today. With that being said, proud to announce our two panelists. They both bring a wealth of knowledge, and I know you'll enjoy their conversations today. First off, we have Rachel Weber. She's a regional sales consultant. She's from Cincinnati, Ohio. She previously spent 4 years in design before joining BPI a year and a half ago. And then we also have Steve Clark. He is the engineering manager at BPI. He's originally from southeastern Wisconsin. He brings 40 years of experience in metals manufacturing and has been leading engineering teams for the past 30 years. So welcome both of you. With that being said, Rachel, Stephen, the floor is yours.
So before we kick off the design aspect, we kind of just, Steve, can you tell us through what makes your design manufacturable and what you need to consider before choosing your path?
Sure. There's been quite a paradigm shift in designing. It used to be that you'd have the end product in mind and the manufacturing method and design straight to the end product. Now we have the 3D printing industry and the rapid prototyping that's available has designers taking an intermediate step where they only consider the requirements, often only consider the requirements of that prototyping, rapid prototyping method. But I'm suggesting that they also clearly consider the end process in mind that is going to be used to produce the parts, to try and incorporate the design features that allow that end manufacturing method to be applied while still accommodating all of the requirements of the rapid prototyping. So I'm just suggesting that that's something they have to keep in mind. And some of the newer designers think about making the first prototypes and they don't think so much about making the final items in production.
So you really have to think about the quantities that go behind the end product and how much you plan to sell of it.
You bet, to choose the proper method to produce the parts.
Okay.
Exactly.
Got it. Awesome.
You got it. Yep.
So there are 7 important permanent mold design standards.
These are designed specifically for aluminum. I would say these standards would be similar to what you'd see with zinc products.
So let's get started. So can you tell us a little bit about wall thickness and why that's important for permanent mold casting?
Well, it's really one of the most crucial parts of the casting process is the wall thickness that you're solidifying, because that really defines how long the solidification is going to take. Okay. And if you have a heavy section right next to a very thin section, that thin section could freeze off and not permit the proper liquid metal fill before the solidification occurs. Okay. So you want to have gradual transitions between section thicknesses wherever possible.
Okay.
That's definitely one of the rule is to avoid those isolated thin or thick sections. If you go below the minimum wall thickness that our process is capable of, we'll end up with the likelihood of voids and areas that just aren't filling out, where the metal will freeze and leave a gap, often one that you could see daylight through, which we try to avoid having any of those that aren't designed into the part. There's a lot of chill in our process because we're using steel molds that can pull a lot of heat out of the aluminum swiftly. You want to make sure that you're backfilling that solidification with molten metal of enough sufficient volume that you actually fill it out and we get the solid metal where we need the solid metal.
So what happens if you do have a part that it requires a thinner section compared to the rest of the casting? Is there other methods you can do to achieve that?
We're going to get to those, actually.
Okay.
There's fillets and radiuses that you can use, and you can use the proper sized fillets and radiuses for those transitions. Can
Okay.
make a big difference in the success of a casting.
Oh, cool. All right, well, there you go. Leads right into it.
And we're right here, fillets and radiuses. The standard that we're talking about today is at least 30 thousandths of an inch. The radiuses make the part stronger. I'd give a preference to a radius over a fillet just because the metal flows more smoothly through a radius than it does through a fillet.
Okay.
Sharp corners in the final product, of course, cause high stresses, cracking, and possibly tearing of the actual part while it's solidifying if it hangs up anywhere on the mold and doesn't release properly and at the right time from the mold, you can actually get some tearing of the part. I would try to aim towards the thickness of the material as a radius wherever possible.
Sure.
You don't want to go too big with the radiuses. You don't want to go too small.
Okay, that's good to know. So machine stock allowance. So obviously permanent mold is cast to shape, so you won't be able to get all the features right away. So the machining has to happen. Where are some tolerances we have to look for?
Right, you bet. Where you want a tighter tolerance than the process is capable of, you want to leave some stock for that machining to make sure you get clean surfaces and you get the proper geometry in the finished part.
So I know draft is something that we talk a lot about. Can you explain the idea behind draft and how you need to use it in a casting?
Sure. This is something that can be a little counterintuitive for a designer too.
Okay.
We want to make sure that designers of parts understand this. Actually, for a shallower feature, a feature that isn't quite as tall or quite as high in the part, you actually require more draft.
Okay.
So the taller the feature gets, the deeper the mold gets, the less draft is actually required.
Interesting.
To make the part work properly in the casting process. And of course, we use the draft to get the part out of the mold. You want the draft to move away from the parting line so that the parts release accurately off the mold. And this is typical of a permanent mold casting where the parts will stay with the top mold, the cope, and they'll be ejected by pins from that cope, onto in this case, a plate that we move into place to catch the castings.
Okay.
And it also, the proper draft permits the mold to last as long as possible. Okay. And I like to think that there's almost never too much draft on a part that's cast. So you can use as much draft as you want. These are essentially minimums that we're recommending.
Okay. And like before, you can always machine away or add a flat surface or polish it down.
You bet. You bet. Yes. If you have a really thin walled part, we can cast it thicker to obtain sound material in that area and then machine it to your final requirements. Now there's a limit, some practical limits as to how thin you can machine materials too. And the other thing to keep in mind is that you want to avoid those big section thickness variations, especially when you're getting to those thinnest of castings. You want to make sure that you have gradual transitions in the part.
All right, so cord holes. What are the purpose of cord holes and how do you dimension them?
So some cord holes end up being final product if they just need a hole through the part for some type of breathing, type of thing.
Okay.
But occasionally the holes being cored can actually save time in the machining operation too. So when you core a hole, it will have some draft as well.
Okay.
And you'll have to, if you want a perfect square-sided hole, you will have to do some minimal machining after the part is cast.
Gotcha. Okay, can you tell us a little bit more about concentricity and why it's important?
So concentricity and total indicated runout, this standard really involves there's two different ways of looking at it. One is if you have a one-sided mold where all the casting is being done in one side and the top is essentially just a closure for the mold. The other one is where you have features that go right across that parting line that we just looked at.
Yep.
So you have parts that go across that parting line. If everything in that casting is in one side of the mold, there are smaller concentricity tolerances that will occur because everything's been machined in the same setting and everything should be relatively concentric in a one-sided mold. When we go across a parting line, though, there can be a slight amount of mismatch at that parting line. The machining has to be done in separate operations, so that's where those concentricity issues develop from the mold itself. The castings will do exactly what the mold does.
Yeah.
So
when it goes across a parting line, the tolerances require a little more ease.
Yep, you need a little bit more room in your tolerances to accommodate the features across the parting line.
Okay, good. So linear tolerances, how does that differ, or what should we look for when we're talking about linear tolerances?
So these are probably the most important tolerances oftentimes to a designer, because they have parts with features. Okay, so here's an example of a part with a lot of features. And as we look at this part, which is for a piece of medical equipment, you can see how many features are on here. And each of these has to be accurately located for the part to successfully function. You can see some machine surfaces on here where they wanted the part to be a particularly close tolerance. And by doing the machining on that, they're able to create that feature. So it's really important that designers understand the capabilities of the permanent mold process. And when they get beyond these tolerances, that's where they have to start thinking, well, I have to machine and take some stock off to achieve my tolerances. But if they're working within these tolerance ranges, then they're good to go with the cast surfaces. Now, I will add that there's a little bit of additional tolerance if there's a core involved.
Got it. Okay.
Now, a core would create a hollow spot inside the casting, and those cores are tied to either the top, either the cope or the drag, the top or the bottom of the mold.
So I assume that every part has a flatness spec. So how do you check it for permanent mold?
Well, flatness is defined as the variation between two parallel planes.
Okay.
So this is the variation that can be expected in a permanent mold casting. Now, the good news is that the tolerances for permanent mold castings all across the board are really tight compared to many other casting processes.
Okay.
You don't get the tolerances that we talked about for position and concentricity and our flatness. You won't get that out of perhaps a sand casting process or some other casting processes, but the permanent mold process using steel molds is capable of very, very high tolerance parts, as you can see with this flatness. So 0 to 6 inch size parts, it's flat within 20 thousandths of an inch coming out of the mold, and then you add the 2 thousandths for each additional inch. Now we're hitting on my favorite part of the flexibility of the permanent mold casting process, because you can put inserts in. In this case, we're looking at a coil, some tubing that can be put in. You can put a heater in. You can cast a heater element right into the aluminum casting. There's pretty much anything you can fabricate or form that fits inside the casting envelope you can put in there. And the way these castings fill in our tilt pour permanent mold casting process, you can be assured that the metal will fill around whatever insert you're using, and that it'll gently squeeze that insert so it isn't a metallic bond, but it's tightly held in place. So it becomes a functional part of whatever you're trying to create. So I'm really excited whenever we get the chance to do some functional inserts. And then the sand cores that, again, can create hollow areas. We do both sand cores and metal cores. Metal cores, there would be a separate slide that would insert that metal core in and then pull it back out before the die is opened up. But those sand cores can create quite a complex geometry inside of a part.
Sure, yeah.
Yeah.
So that you can be able to, whether it's run channeling, like wire channeling through it and such. Okay.
Yeah.
All right.
What specifically do you need to look for when adding in, design with the core in mind?
Well, the core has to be supported somehow. So there has to be a way for us to hold the core on one of the mold sections, typically the bottom. So that's really important that we can't make a totally enclosed space like a hollow ball type of thing, because there's no way to hold the core in that mold, and there's no way to extract that core after you're done with the casting process. If you want to core a part like that, I think communicating early on with your sources. We at Batesville Products really pride ourselves on supporting customers that are designing, not just waiting for the purchase order, but actually working with them at the design stages and helping them determine what makes sense for their product.
Yeah. I will say from my experience, I think things that go the smoothest are when you're given, here are my features that are required, they cannot change, and here's the features that we're open to change, and that allows it to be a little more flexible and work better for the process.
Yep, and then we start our manufacturability job and help create the design, the dimensions that are producible.
Yeah. All right, I believe we've hit the end of it in terms of tolerances or how you design a permanent mold part.
Thanks everybody for joining us today. Thank you, Rachel and Stephen, for your insight. Thank you guys, and we appreciate everybody for attending.
Thanks, Jonathan.
Thank you.
Thank you. Thank you.
You're listening to Casting Class, an engineer's guide to manufacturing aluminum castings, hosted by Batesville Products. Be on the lookout for our next casting class on the first Wednesday of every month. Until then, you can find more resources like videos, written guides, and case studies on our website, batesvilleproducts.com. That's batesvilleproducts.com. See you next month.